for summer 2015. Question 7, QP11, question paper 11, question 7. A part says that the third and fourth terms of a geometric progression are 1/3 and 2/9 respectively. Find the sum to infinity of the progression. B, a circle is divided into 5 sectors in such a way that the angles of the sectors are in arithmetic progression. Given that the angle of the largest sector is 4 times the angle of the smallest sector, find the angle of the largest sector. So the question says that the third and fourth term of a geometric progression are 1/3, 2/9 respectively. We want to find the sum to infinity of this problem. What do we do? You need to remember, quickly quotes, what a term of the geometric progression is. And we know that for a geometric progression, the Tn, which is any term within a geometric progression, is given by a r to the power n minus 1. You remember, where a is the first term, r is the common ratio, and the n is the number of terms that are there. So we'll just try and do a replacement with the information that we have and resolve it and see what happens. Okay, so when we are saying the third term means that T3 is equal to a, which we do not know, a r n minus 1 is the third term, so here will be squared. Hope you're okay with that. That's going to be squared. All right, so our third term is 1/3. Hence, we can say that 1/3 is equal to a r squared. Hope you are clear with that. Now, the same goes for the fourth term, which they say is 2/9. The fourth term is 2/9. Okay, so what do we say? We can say T4 is equal to 2/9. And what is T4? T4 is going to give you AR cubed. Hope you know why it is cubed, because the top is going to be 4 minus 1, and 4 minus 1 is 3. So AR cubed is equal to 2/9. Okay, so now when you look at it carefully, you can see that your AR squared is equal to 1/3. Okay, AR cubed is equal to 2/9. The problem wants us to find the sum to infinity. And if you know the rule for the sum to infinity, let's just code it here a bit for emphasis. The sum to infinity we know of a geometric progression is a over 1 minus r. Hope that is clear. So the only two things that we need to find to help us to get the sum to infinity is to identify what the first term is, what a is, and also to find the common ratio. Hope that is clear. So interestingly, you will find out that in this portion, you have an AR squared and an AR cubed term. So what do? Okay, so we just put them side by side. AR cubed is equal to 2/9. We also know that our AR squared is equal to 1/3. So what happens? We just try and resolve them. So we divide the terms. You divide the expressions. So the AR squared, the AR cubed is equal to 2/9 will be divided by AR squared is equal to 1/3. Remember, we do this division because the terms are combined by multiplication. So once they are products, the only way you can split them is to divide them. Okay, so when you divide, what happens? Let's just put the division symbol here. Okay, so you're going to have AR squared, AR cubed all over AR squared, cancelling that, and that's going to give you your R. And what is 2/9 divided by 1/3? Okay, let's see that. So 2/9 divided by 1/3 is going to give you 2/9 times 3/1, right? So this will take off that. That's going to give you 2/3, okay? So your common ratio is 2/3. Have a look at that. So we now have our common ratio being equal to 2/3. Since our R is equal to 2/3, we can slot that in to identify what our A is. What is your A? You can put the R into any of that. Let's say that you put the R into this expression. Okay, so 1/3 is equal to A R squared. What happens to that? Now, if you're able to do the substitution, which I know you can work out with, your A is going to give you, following that, you're going to get 3/4. Okay? That's just a piece of algebra. I think you can just simplify. You just put your R in there, resolve it. Your A should give you 3/4. So now that you have your common ratio being equal to 3/4, what do? We can now find our sum to infinity. We therefore say that our sum to infinity is going to give you A, which is 3/4, divided by 1, okay? 1 minus 2/3. Okay, so what's going to be the result for our sum to infinity when we do that? Our sum to infinity, following a simplification of that, should give you 2. Hope you are clear. All right, so the bit of algebra, I've just left you for you to do that, okay? You can just use your algebra. Your calculator can even work that out for you. So with our first part of our problem, that is what we get for our common ratio. 2/3 being our common ratio, a is equal to 3/4. Then the sum to infinity, the value for the sequence as it converges will be 2. Okay, so for the B part, we are being told that we have a sector of a circle. Now, for that particular sector of the circle, we have divided it into 5 parts, okay? Like this, angles have been divided for the sector of a circle, like into 5. All right, so we can say that, as we know by convention, most times the angles are referred to as theta. So if it is being divided into 5 parts, you can have theta 1, theta 2, theta 5. Now, that is the description we use. You may choose to use another thing else. Now, a very important fact that is being spoken about in the problem is that we are saying that the largest part, okay, the largest part, and in fact, it says that in arithmetic progression, that's what the question says, arithmetic progression. So what that means is that if you move from your first angle to your second angle will be bigger than your first one, and your third will be bigger than your second, and like that. So the problem is saying that the largest angle, okay, which we can obviously refer to as theta 5, is 4 times the smallest. The largest is 4 times the smallest. So we can therefore say that theta 5 is equal to 4 theta 1. Remember, the theta is being used to designate the angles. All right? Okay, and we are saying that it's in arithmetic progression. That's what the problem tells us. Now, the question we are being asked to find is that we want to find the angle of the largest sector. What is our interest is to find theta 5. Now, because we've been told that it's an arithmetic progression, we just try to rewrite this in terms of the arithmetic, the AP terminologies. So here, we will just say that our T5 is equal to 4 times T1. Okay, our T5 is equal to 4 times T1. Now, let's now use the rules of AP and see how we resolve that. We know that for an AP, the nth term is equal to A plus n minus 1 D, where D is a common difference. So let's see what T5 will be. We can therefore say that T5 is A, okay, which is T1, okay, plus T1 plus n minus 1, and our n is the term, so this is going to give us 4 minus 1, and our common difference, that's what we don't know, let's call it D here. So we say T5 is equal to T1 plus 3D. No, 4D, okay? Because that side is going to be n, so T5, that's going to be 5 minus 1. Sorry, just correct that. Let's just correct that. So that side is going to give us 5, okay? Okay, so we're going to have 4D here. So we have T5 is equal to T1 plus 4D. Okay, now the problem is also saying that T5 is equal to 4T1. So we can replace T5 by 4T1. Hence, we can say that 4T1 is equal to T1 plus 4D. Hope that is okay. All right, so now let's see what happens. We can put the two together. All right, so the simple expression that can be generated out of that is that 3T1 minus 4D is equal to 0. Hope you're okay with that. Because 4T1, when you bring the T1, that's going to subtract. So 3T1 minus 4D is equal to 0. Or we can say that 3T1 is equal to 4D. That is also 1. So that's the first expression that we get. Now, another fact that we know is that because it is a circle, okay? Because it is a circle, because the question says there's a circle that has been divided into 5. What do we know for the sum of the angles in a circle? When you add all the angles in a circle, what do you get? 360, okay. So what it means is that if we were to put all, the 5 sectors together, we should get 360. That therefore shows us that S5, okay, which we know 5 over 2 from the rules of what we know for about the sum. Sn is equal to n over 2, okay, into brackets 2a plus n minus 1d. Okay, so we're going to have 2t1, because remember, in place of a, we put t1, which is our first term, okay. 2t1 minus, okay, 2t1 plus. Okay, so what is our n minus 1? Again, 5, so 4 D. Hope you are fine with that. Are we okay? All right, so what is the sum of the total angle in the circle? This is going to give you 360. So 360 is equal to 5 over 2, 2t1 plus 4d. Hope you are clear with that. Hope you are clear. So now let's just try and resolve our expressions and see what we get. Now, if we were to resolve this, okay, if we were to put this together, that's going to give you 720. Because the 2 goes there, then you are going to have, let the 5 go in there. So you're going to have 10t1, okay, plus, then the 5 multiplies the 4. What do you get? 20d. Guys, hope you are fine. Okay, so now we see 720 is equal to 10t1 plus 20d as another expression that could be generated when we use the fact that the sum of the circles, angles in a circle should give you 360. So we have an expression that connects t1 and 20d. We have another expression that connects 3t1 minus 4d equals to 0. So what do? We put the two side by side, okay? So we can say that 0 is equal to, let's put t1, 3t1 minus 4d. Okay, so we just try and solve these two simultaneously. Now with your calculator, you can just work this out simultaneously. When you work it, what do you get? Solving this simultaneously, basic algebra. If you're able to use simultaneous equation, what will you get? All right, so with that, our A is going to give us 28.8 and our D is going to give us 21.6. All right, so our first term is going to give us 28.8 and our second term, our common difference is going to give us 21.6. All right, so with this, what is our T5? Our largest sector. T5, we know, should be equal to, now when you watch the T1 plus AD, remember T1 is our first term. So the A that we see is the same as our first term, okay? All right, so our T1 is going to give us 28.8, okay, plus 4 times plus 4 into bracket 21.6. I hope you're okay. All right, so when we put all that together, we are going to get 115.2 degrees. So the largest angle of the sector with the largest angle is going to be 115.2 degrees. And that is how the AP concept can help you to resolve that. That brings us to the end of the QP 11, question paper 11, question 7 for 2015, how you solve the B part. (2015) question 8, QP 12, the A part. The first, second, and last terms in an arithmetic progression are 56, 53, and minus 22 respectively. Find the sum of all the terms in the progression. The B part, the first, second, and third terms of a geometric progression are 2k plus 6, 2k, and k plus 2, where k is a positive constant. I. Find the value of k. II. Find the sum to infinity of the progression. Okay, so for the second variant question, QP12, question 8 was what was just shown to you on your screen. And the important facts of it is that we have the first, second, and last term of an arithmetic progression being 56, 63, and negative 22. So let's just try and identify those things quickly. So we have 56, 53, and minus 22. Okay, so this is the first term according to the problem. And we have our second term, okay. So let's call this T2. Okay, let's just adjust this one briefly. So we call this T1, T2, and our last term is that, okay. So the question says that we should find the sum of all the terms in the progression. We want to find the sum of all the terms in the progression. How do you find the sum of all the terms in the progression? How do you find the sum of all the terms in the progression? All right, so we have our last term equal to that. Now, we could use what we know for the sum, okay, of of the terms. So we need to identify the number of terms that we have in the problem. Okay. Now we know that for an arithmetic progression, when we know the last term, we can say that our Tn relation, let me just check that. Now watch, our Tn is a plus n minus 1d. Remember, Tn is a term, any term within an AP. In an event where the last term is there, we know that the last term could be written as L, okay, where you have the last term, such that the n now becomes the number of terms in the AP. The moment you put n being the last term, okay, then the n refers to the number of terms in the AP, because by the time you get to the last term, the designation on that number of terms is logically the number of terms that you have in the AP. Does that make sense? Okay, so when we have the last term, the n that now appears within the relation becomes the number of terms. And it's important for you to know the number of terms before you can find the sum of the terms. How do you sum what you don't know? Okay, all right, so we need to find n. Okay, so L is equal to a plus n minus 1d. What is our a? Our a is 56, as we know it, plus our n, in this case, the number of terms which we do not know, we have n minus 1, and our d, let's look at our common difference. Now, 56, 53, the difference is going to give you minus 3. Remember, it's a negative difference, so we're going to put negative 3 here. Okay, and we also know our last term to be minus 22, so we can say our minus 22 is equal to 56, 56 minus 3n plus 3. All right, so now if you're able to work that out, if you're able to deal with that, what do we get for our n? What do we get for our n? When we go to the algebra, our n should give us 27. Now you can just confirm that in your private working. So our n is going to give us 27, which means that this particular AP has got 27 terms. The AP has got 27 terms. So now how do we find the sum of the terms? How do we find the sum of the terms? All right, we know that the sum of the terms in an AP is n over 2 into brackets 2a plus n minus 1d. All the components have been found. So we want to find the sum of those 27 terms. Okay, the sum of those 27 terms. So the S of the 27 terms is going to give you 27 over 2. Then remember, you just do the substitution nicely, okay? So A is 56, so 2 times 56 plus, what do we do? N minus 1. So that's going to give you 26 times minus 3 and all that, okay? So we just try and do that simplification. Now, when you do that, you should get 459 being the sum of your 27 terms. So remember the approach. Find the number of terms, which is your n, where your last term is given, and you also input those values neatly in there to give you the sum of your 27 terms, being 459. And that is what the A part of the question 8 of the QP1 will give you. All right, so the B part of the problem, as was seen, is that we have the first term, the second, and the third term of a GP. This time we say geometric progression, okay? So this is your T1 for a GP, your T2, and your T3. The first, second, and third term of a geometric progression. And the problem tells us that K is a positive constant, and we want to find the value of K. Now, the key thing you need to know in this problem, always, and remember, if you've not seen it, I once again refer you to our revision courses on series and sequence for P1, P1 1. It's on our website at www.learnwestafrica.com. Please, you can just go there and subscribe, and you have an in-depth knowledge about some of these parts, okay? And you have any clarifications, I'm sure that that set of videos will extensively clear those dust off your eyes, okay? All right, so back to our question. For geometric progressions, their key component is the common ratio. A division of the succeeding term over the preceding term should give you a constant value, which means that when you divide your second term over your first term, what you get should be the same as your third term over your second term, and it goes on like that. So we can say that our 2k, which is our second term, all over 2k plus 6, okay, should give us, so this gives a common ratio, should be the same as k plus 2 all over 2k. Hope that is okay. All right, so now we just have a simple algebraic situation on hand. We can just cross multiply both sides. Okay, so you have 2k dot 2k, okay, is going to give you k plus 2, then 2k plus 6. So that's going to give you 4k squared, then equal to an expansion of that, k plus 2, 2k plus 6. Now, if you do that quadratic, if you do that, you realize that's going to give you a quadratic function that you'll be able to solve, okay? So for the quadratic, we're going to get values of k being equal to 6 and k being equal to minus 1. And remember, the question is giving us a prompt that k is a positive constant. So once our quadratic gives us two values of 6 and negative 1, and our k is a positive constant, we have no choice than to select the k equal to 6, being the answer that satisfies the problem at hand. Okay? So our k, we will say, is equal to 6. Please just try and make sure that you do your quadratic. I'm sure it's very simple with your basic algebra. Complete the quadratic and confirm that your k is equal to 6 and minus 1. With that, your k should be equal to 6. All right, so the IR part says that on the basis of this, we should find our sum to infinity. On the basis of this, we should find our sum to infinity. So how do you find your sum to infinity? We know that your sum to infinity of a geometric progression is a all over 1 minus r, where r is our common ratio, okay? So now, with that, we should be able to resolve that. What is our a? Our a is 2k plus 6. So we know that our a is 2. If our k is 6, okay, plus 6, you're going to have 12 plus 6. And your a is going to give you 18. Understood? All right. Then you can also work out the value of your r. You can also work out the value of your r. Now, when you do that for your r, you are going to realize that your r, after slotting your r into 2k over 2k plus 6, please, you can try and also confirm that you put 6 in there. Your r, your common ratio, should give you 2 over 3. Okay? Your common ratio should give you 2 over 3. So, with your a equals 18, your r being equal to 2 over 3, your sum to infinity should give you 18 all over 1 minus 2 over 3. And with a bit of workings or calculations, our sum to infinity should give us 54. Okay, so that brings us to the B part of our problem for that. Question paper 1-3, question 9. A. The first term of an arithmetic progression is minus 2,222, and the common difference is 17. Find the value of the first positive term. The B part. The first term of a geometric progression is root 3, and the second term is 2 cos theta, where theta is in between 0 and pi. Find the set of values of theta for which the progression is convergent. Okay, so in our third variant, question 9 is asking something very interesting. As you saw there, that the first term of an AP is minus 2,222, and the common difference is 17. You want to find the value of the first positive term. So let's look at the key facts there. Now we are saying that our first term, T1, is equal to minus 2,222, and our common difference is 17. So our D is equal to 17. These were the key facts that the problem told us or made us know. And we want to find the value of the first positive term. Now, how do we deal with that? Value of the first positive term. Now, you should know that when we say the positive term, okay, a positive term, simply put, we are looking at that term that is greater than 0. True or false? Yes, because it's at a point of 0 that we have the boundary between negative values and positive values. Okay, so simply put, we are looking for a situation, okay, of n, a particular term, Tn, where that Tn is greater or equal to 0. So what is that? We are looking for where your Tn is greater or equal to 0. What is going to be the value of that n, okay, where this relation is going to be greater than or equal to 0. Now we know that our Tn, okay, is always a plus what? Our n minus 1 d. Okay, so what we simply have to do is to try and replace our Tn with this so that we can satisfy the problem. So simply, we are looking at the case where our a plus n minus 1 d should be greater or equal to 0. What is going to be the value of that? What is going to be the value of that? What is going to be the value of that n? Such that it will make this relation 0, like greater than or equal to 0. Hope you're okay. Because positive, that's what we need to find. Greater than or equal to 0. You enter into the positive realm. So now we have our value of T1, which is minus 2,222. We have our common difference, which is 17. The only thing that we don't know is our n. So we just slot the values of that in there and determine what our n is. So we are going to have minus 2,222 plus n minus 1. And our d is 17 greater than or equal to 0. So this is the basic relation that we are looking for. And what do we do? Okay, now if you're able to solve this inequality, which I'll expect you to be able to solve, okay, just solve it and just post your answer, send your answer to me on the email as you find on our website, or you can also reach me personally on that. Okay, so when we're able to do that, you realize that your n will be greater than or equal to 131.7. So when your n is greater than or equal to 131.7, you are going to have your terms there. So the smallest point term where you get that, obviously, is going to be that the 131st term, 131st term should give you a positive 1, okay? If you are greater than 131, you've entered into the realms. And remember, when you look at the point, this, when you run up, it's going to give 132. So once you have more than 132, you are sure that you've entered the positive. So on your 131st term, you would have passed the negative terms. And that is what question 9, first part, helps us to get. All right, so for the B part, it's a geometric progression. It's a geometric question, as you can see there. As you can see there. So we are saying that the first term of a geometric progression is root 3. So the first term, okay, let's T1 is equal to root 3. Then we are being told that the second term is 2 cos theta. So T2 is equal to 2 cos. 2 cos theta, all right? And we are saying that where your theta is between 0 and pi, okay? So we want to find a set of values of theta for which the progression is convergent. Now, when we say progression is convergent, remember, it is an indication that we are interested in to find the sum to infinity. Because the sum to infinity is always existent or exists or can be found when the progression is convergent. Where the progression is divergent, it does not end at a point. You cannot find the sum to infinity. That's a fact you need to remember. All right? All right. So we know that for a GP, a sum to infinity is always known as 1 over a over 1 minus r. That's a very, very important thing to know. Now, our first term is given as theta, and our second term is that. So we know that our A, which is our first term, is equal to root 3, okay? And our second term, which is AR squared, okay? Our second term, which is going to be AR, okay? It's going to give you 2 cos theta. 2 cos theta. Hope you are clear with that. All right, 2 cos theta. So with this, we can now find our r. We can say that our r is equal to 2 cos theta all over our a. Our r will be 2 cos theta all over root 3. Hope you are clear with that. All right, so now we have our relation like this. We have a relation like this. So our first term is root 3, AR is equal to that. Now, for our sequence to be convergent, you should know that your common ratio cannot be more than 1. You understand that? Because once the common ratio is more than 1, the sequence would increase. It becomes divergent. You can't have a convergent situation. So we are looking for a situation where our R has to be less than 1. So what will be that case? Where your R, which is your 2 cos theta all over root 3, should be less than 1. What is that going to be? So clearly you have a case of a trigonometric problem on our hands. So we can say that our 2 cos theta should be less than root 3. So our cos theta should be less than root 3 over 2. Right? Hope you are making sense here. All right. So with that understanding, it should be easier for us to work out, assume what our cos theta is. Now, from your basic trick, if you were to find the value of your theta using your trigonometric ratios with the respective angles, your theta should be less than pi over 6 in radians. And on the other hand, because we are saying that it falls between the period of 0 and that 2 pi, then your theta should also take a value of your theta should be less than pi over 6. And for the second quadrant, okay, in the second quadrant, you're going to have your theta being equal to 5 pi over 6. So these are the values of theta for which your progression is going to be convergent. Remember the key fact. For convergence, the indicator is dependent on your common ratio. Once your common ratio is less than 1, your sequence is going to be convergent. So that is the key idea that we try to use, and we just slot that with our basic trigonometry. We have cos theta less than root 3 over 2. I'm sure you know that from your IG, add mass, and when we resolve that, we should be able to get our theta being equal to pi over 6 or that. So because of the range that was given, if it's either pi over 6 or 5 pi over 6, you should be able to have your sequence being convergent. That is question 9 for you.